Hello everyone, welcome back to my topic where we make math fun and exciting. I'm Nitin Joshi and today we are going to explore the fascinating world of rational number. This is your second lecture of a rational number. So let's begin. First, as we studied in our last video lecture, I have done introductions. Basically learn about we have all studied in our previous classes natural number, whole number, integers, rational numbers. This rational number, their properties, we will read approximately first closure property, second associative property, third commutative property, fourth distributive property, and then we will solve the exercise questions. So let's start natural numbers. In our previous lecture, we studied that natural numbers are denoted by with n, which start from 1 and goes up to infinite. Whole number start from 0 and goes up to infinite, denoted by w. Integers are the natural numbers and their negatives, denoted by z and I, start from negative infinite and goes up to positive infinite. Rational numbers, any number which can be represented in a form of p upon q is called a rational number, and where q is not equal to 0, both the numbers are integers. Q is not equal to 0. Here the properties first closure property. And this closure property means for two rational numbers x and y, the results of addition, subtraction, and multiplication operations give a rational number. We can say that rational numbers are closed under addition, subtraction, and multiplication. For example, 7 by 6 plus 2 by 5, and the LCM is 30. We get 47 by 30, which is a rational number. Again, for 5 by 6 minus 1 by 3, we get 1 by 2. It is also a rational number. 2 by 5 multiply 3 by 7, which is equals to 6 by 35, which is also a rational number. The division. Do you know why division is not under a closure property? The division is not under a closure property because division by 0 is not defined. If you divide any number, like we take 15, if you divide it by 0, this is not defined. It means we can also say that except 0, all the numbers are closed under division. Commutative property. For rational number, addition and multiplication are commutative. Means in this property, the answer remains same despite the changing the position of the numbers. So means it is only applicable for addition and multiplication. What I said that if we change the position of the numbers, the answer will remain same. This is a commutative property. Like example, we take 2 by 5 plus 7 by 9. LCM will 45, 18 plus 35, which is equals to 8 and 5. 13, 3, 1 carry, 3, 4, 5, 53 by 45. It is a rational number. If I change their positions, means 7 by 9 plus 2 by 5. Is it change the answer? No, the answer will remain same, which is equals to 53 by 45. And for multiplication, this is also same. For multiplication means A multiply B is equals to B multiply A, means if I will take relation 1 by 3 multiply 7 by 8, this is equals to 7 by 24. If I change their position, is it change their answers? No. The answer will remain same, which is equals to 7 by 24. It means commutative property, commutative law of addition is A plus B is equals to B plus A, and commutative law of multiplication is equals to A multiply B is equals to B multiply A. In this property, there is not a single change in the answers if you change their positions. Associative property. This is likely same as a commutative property. Rational numbers follow the associative property for addition and multiplication. Suppose x and y, x, y, and z are rational number. Therefore, addition x plus y plus z is equal to x plus y plus z. For multiplication, x, y, z brackets are used. Here 1 by 2 plus, sorry, here 1 by 2 plus 1 by 4, it is in a bracket plus 2 by 3, means LCM is 12, and here 3 plus 8, which is equals to 11 by 12, page 1 by. I will take the next new example like what 1 by 2 plus 1 by 4 plus 1 by 3. Means that the LCM is 12, and we get here 3 plus 4 brackets are used. 1 by 2 plus bracket 7 by 12. Again, the LCM will same 12. Here you get 6 plus 7. We get 13 by 10. If I use the bracket here, the LCM will 4, and here we get 2 plus 1 plus 1 by 3 brackets used. 3 by 4 plus 1 by 3. LCMs are 12. Here 3 threes are 9 plus 4. We get 13 by 12 again. It means in this property, if you change the positions of bracket, it will never change the answer. And this is same for multiplication. This is same for multiplication. It means if I take 1 by 2, multiply 1 by 3, multiply 1 by 4, 1 by 2, multiply 1 by 12. And here we get 1 by 24. If I change the position of bracket, means 1 by 2 multiply 1 by 3 is in a bracket, and outer side multiply 1 by 4, which is equals to 1 by 6, and multiply 1 by 4 is here is equals to 1 by 24. We will never change the answer despite you change the position of bracket. So next, distributive property. From here we start a new point. We all have covered all the topics which we recently completed up to associative in our last video lecture. Distributive property. The distributive property states A, B, and C are three rational numbers, then it is the distribution of symbols which is present outside the bracket. It means A multiply B plus C is equals to A multiply B plus A multiply C. Also for subtraction, A multiply B minus C is equals to A multiply B minus A multiply C. You can see here that it is applicable for addition and subtraction. Both the LHS and RHS are equal. First of all, A multiplied by B, then we use the symbol, and then in the second term we multiply A by C. A multiply B, and then we use addition symbol, and then we multiply A by C. A to C. The same is in this. Here LHS is equals to RHS. In this, the distribution of multiplication symbol in the bracket of equal means first A multiplied by B, then A multiplied by C. We'll go up to next, identity and inverse property of rational number. We have to remember two numbers, 1 and 0. 0 is additive in identity, and 1 is multiplicative identity. What does it means? Identity means there is no change of applying them into the operation. It means for additive identity, it is 0. If I add any number to 0, or 0 to any number means I'll take 57. And if I add 0 in it, will it change? No, will not change, and the answer remains same, which is equals to 57. That's why we call 0 as additive inverse. And for multiplication identity, which is equals to 1, it means if we multiply any number by 1, we will get the same number again. It will not change the answers or not change in the number. It means I'll take 87 multiply 1 is equal to 87. Again, the answer is same. Inverse property for rational numbers x and y. For a rational number x and y, the additive inverse is minus x by y, and yx is the multiplicative inverse. What is it means? Additive inverse. In addition, the additive identity is zero. It means in additive inverse, you will get the answer zero. And in multiplicative inverse, you will get the answer one. The additive inverse of any number, like we take 2 by 3. Its additive inverse is minus 2 by 3, which is equals to 0. And for multiplicative inverse, if we take 2 by 3 as a number and then its multiplicative inverse is 3 by 2, which is equals to 1. As I told you, in additive inverse, we will get the answer 0, and in the multiplicative inverse, we will get the answer 1. And additive identity, we add 0, and multiplicative identity, we multiply the number by 1. Exercise 1.1. Let's start the exercise 1.1. First question is the question number 1. Using appropriate property, find what we have to find. Okay. The first question is here. Minus 2 by 3 multiply 3 by 5 plus 5 by 2 multiply 3 by 5 and multiply 1 by 6. So let's start. What is the associative property? Associative property, just a minute. The solution will start the solution here. Minus 2 by 3 multiply 3 by 5 and minus 3 by 5 multiply 5 by 2. Sorry, there is not a multiply 1 by 2 here, is it? Multiply 1 by 6. Multiply 1 by 6, then add 5 by 2. Here 3 by 5 is common. I'll take it outside. Minus 3 by 5. Or 3 by 5, I'll take 3 by 5. And inside we get minus 2 by 3. Minus 1 by 6. And take it to here now plus 5 by 2 is equals to 3 by 5. And the LCM in it is 6 minus 4 minus 1 and plus 5 by 2. We will get here 3 by 5 multiply minus 5 by 6 plus 5 by 2. Here 5 to 5 cancel out, and here we got minus 1. It means we'll get 3 multiply minus 1 by 6 plus 5 by 2. Right. We get minus 1 by 2 plus 5 by 2. LCM 2 minus 1 plus 5, which is equals to 4 by 2. And which is equals to 2. We will get the answer 2. I will do properly here. A question is minus 2 by 3 multiply 3 by 5 plus 5 by 2 minus 3 by 5 multiply 1 by 6 minus 2 by 3 multiply 3 by 5 minus 3 by 5 multiply 1 by 6 plus 5 by 2 and take common outside means 3 by 5 but outside the bracket and we get minus 2 by 3 minus 1 by 6 plus 5 by 2 which is equal to 3 by 5 bracket LCM is 6 minus 4 minus 1 plus 5 by 2 then we get 3 by 5 multiply minus 5 by 6 plus 5 by 2 plus 2 5 cancel out and 3 by 6 we get minus 1 by 2 plus 5 by 2 and the LCM is 2 we get minus 1 plus 5 we get 4 by 2 which is equals to 2 plus 2 is our answer. The next question of this point is your answer which is 2 by 5 multiply 3 by minus 7 close minus 1 by 6 multiply 2 by 3 plus 1 by 14 multiply 2 by 5. This is your homework. Second question. Write the additive inverse of each of the following. Means additive inverse means the negative of the question. The additive inverse of 2 by 3 is equals to minus 2 by 8 for minus 5 by 9. The additive inverse is 5 by 9. For minus 6 by minus 5 minus cancel out. We'll get 6 by 5. Its negative additive inverse is equals to minus 6 by 5. For 2 by minus 9, it means minus 2 by 9. Its additive inverse is equals to 2 by 9. And for 19 by 6, it means minus 19 by 6. Its additive inverse is 19 by 6. Verify that minus x is equals to x for the first one is x is equals to 11 by 15. X is equals to 11 by 15. We have to prove that minus x is equals to x. It means, first of all, we put x in the place of x, we get minus 11 by 15 is equals to 11 by 15. Yes, it is. Minus multiplied by minus, we get plus. Means positive 11 by 15 is equals to 11 by 15. LHS is equals to RHS. The second one is homework. The fourth question. Question number 4. Find the multiplicative inverse of the following. Means multiplicative inverse, it means you have to 1 in the answer. It means the multiplicative inverse of minus 13 is equals to 1 by minus 13. For minus 13 by 19, the multiplicative inverse is minus 19 by 13. For 1 by 5, the multiplicative inverse is 5. For D, means minus 5 by 8 multiply minus 3 by 7, you will get 15 by 56. The multiplicative inverse of 15 by 56 is equal to 56 by 15. For minus 1 multiplied to minus 2 by 5, it means it is 2 by 5 and the multiplicative inverse is 5 by 2. For minus 1, 1 over minus 1 is multiplicative inverse. For the fifth question, name the property under multiplication used in each of the following. Means we have to answer the question. We should see the equation and think about what equation is using in it, what property is using in it. Means minus 4 by 5 multiplied 1 is equals to 1 multiplied minus 4 by 5. It is the multiplicative identity. If 1 is multiplicative identity. For the second one, minus 13 by 17 multiply minus 2 by 7 is equals to minus 2 by 7 multiply minus 15 by 17. It is a commutative property. Despite the change in the position of the numbers, we will get the same answer. Is it commutative property? For the third, minus 19 by 29 multiplied 29 by minus 19, we will get no 1. It means we are using here multiplicative inverse property. Multiplicative inverse property. For the sixth question, question number 6, multiply 6 by 13 by reciprocal of minus 17 by 16. In this question, we have to multiply 6 by 3 by the reciprocal of minus 7 by 16. Reciprocal of minus 7 by 16 is equal to minus 16 by 7. Means 6 multiply according to question. 6 multiply 13 multiply minus 16 by 7. 6 are 96 minus 96 and 13 7 are 19. We will get the minus 96 by 91. Question number 17. Exercise. Tell what property allow you to compute 1 by 3 multiply bracket 6 multiply 4 by 3 bracket closed as 1 by 3 multiply 6 bracket closed multiply 4 by 3. Here, as I told you, the commutative property and associative property have same things, but there is a difference in their properties. In a commutative property, we are changing the position of the numbers, and in the associative property, we are changing the position of bracket. And in this question, the position of bracket is changing. It means I have to answer by using associative property using associative property of multiplicative or multiplication, sorry, multiplication A multiply B multiply C is equals to A multiply B multiply C. By using associative property by multiplication, we are doing this. Question number 8, exercise 1.1. Is 8 by 9 the multiplicative inverse of minus 1 by 8? It is in a mixed fraction. It is in a mixed fraction. Minus 1 by 8. Why or why not? Let's see. Since multiplicative inverse of rational number A is multiplicative inverse of A, of a rational number A, number A is 1 by A. If A multiply 1 by A is equals to 1, therefore 8 by 9 multiply minus 1 by 8 will be equal for 8 by 9 multiply minus 1 by 8 by 9 multiply on solving the mixed fraction, we will get minus 9 by 8 and you get minus 1. But the product must be positive. The product must be positive or multiplicative inverse. Therefore, 8 by 9 is not the multiplicative inverse of minus 1 by 8. Next question. Question number 9 of exercise 1.1 is 0.3 the multiplicative inverse of, here is in a mixed fraction means 3 by 3. Multiplicative inverse. So first of all, we will change the decimal into fraction. It means its answer is 3 by 10. And the answer of this is 3 multiplied 3 plus 1 means 10 by 3. For multiplicative inverse, this is must that you get the answer 1. And the answer is 1. It means therefore yes, 0.3 is the multiplicative inverse of 1 by 3. the rational number. Question number 10, exercise 1.1. The rational number does not have a reciprocal. Which rational number doesn't have any reciprocal? 0. Second, the rational number that are equal to their reciprocals. 1 and -1. The rational number that is equal to its negative. 0. Fill in the blanks. 0 has no reciprocal. No reciprocal. The number 1, the number 1 and -1 are their own reciprocals. The reciprocal of -5 is -1/5. Reciprocal of -1, reciprocal of 1 by x, where x is not equal to 0, is x. The product of two rational number is always a rational number. The reciprocal of a positive rational number is positive. So here we complete the exercise 1.1.